Hello and welcome to this Strong Learn video on circle theorems. It's the fourth video in this series, and in this video we're going to be looking at the alternate segment theorem, and we're also going to look at an example of a trickier kind of question as well at the end. So the final circle theorem states that the angle between a tangent and a chord is equal to the angle in the alternate segment, otherwise known as the alternate segment theorem. It's quite a mouthful, and you can just write alternate segment theorem. That is allowable in the exams when you're asked to give a reasoning to support your answer. So let's break this down and think about what it means. So just going to put my pen out. So the angle between a tangent and a chord. So for instance, here we go. Here's a tangent and here's a chord, is equal to the angle in the alternate segment. So if I look at the opposite segment where I've drawn in, I'm looking at the angle in the opposite segment. Okay, so it's looking at that x, which is the same. And I can do the same using the y. So the angle between the tangent and the chord is equal, so now I'm looking at this line here as my chord, is equal to the angle in the alternate segment. So there we go. Okay, so let's look at applying it here. It's relatively nice to apply if we've got a simple diagram like this. So x is equal to 40 degrees because x makes an angle there with the chord, and then the opposite segment is up the top. And likewise, the 70 and the y works the same way. So y is 70 degrees, and there we go, we're done. Now what makes this tricky is when you start having other lines in it, and it's difficult to spot where the alternate segment theorem can be applied. A key thing to look for is when you have, well, clearly you need a tangent, and you've got a triangle where one of the vertices of the triangle meets the tangent. Okay, not at a right angle, although there's no reason why this rule can't apply with right angles, but that is the kind of thing you're looking for. So here are some questions to try using that theorem, or maybe some of the previous theorems as well. And the answers. And now let's look at something a bit trickier. So we've got a diagram here. We've got no numbers. We've just got 3 letters. And we're asked to show x plus 2y plus z equals 180. So this is going to be quite tricky to know where to start. So a good idea is just to start working out whatever you can. Okay, so what can I do? Well, if I use angle BDF, which is the y, I can say that's angle equal to angle BEF. So this one up here. And that's because they're angles in the same segment. That was the circle theorem number 3. And that's because they share, or both of them have vertices on B and F, that chord BF. Okay, now it says show that, so we need to write some of this down. And it might turn out I don't need that angle, but it's not a bad place for us to begin. So I'm going to write down BDF equals BEF. Now usually you have to give reasoning for your answer as well, and that's in word form. So BDF equals BEF, and I'm going to write angles in the same segment are equal. So there we go. Okay. What else can I do from here then? Well, if I think about triangle BFE, no, not BFE, sorry. Actually, there's not really any reason why I can't use BFE, I can think about angles in the alternate segment. And that's going to tell me that this angle here is Y. And in fact, I could do that from using BDF as well, because both of those are in the alternate segments, or both of those angles are in the alternate segments along my Y is. So let's write that out. So CBF equals BDF, and that's because of the alternate segment theorem. Okay, can I do anything with this X? It feels like I should be able to do something with this X. Let's have a think about this. I guess I could say that I've got this angle BFC to try and work with. So can I get anything with that angle there? Just thinking, because I've then got Y and Z that are both in that triangle, so can I do anything with that? Now X is in a triangle with E and F and B. But I don't think I can use the alternate segment theorem because I haven't got any tangent at F. It's not a tangent that's there. So let's think about what else we can do from this. Can I work out anything to do with a straight line using ABC? Unlikely, because I'm not really getting anywhere with Z. Now at this point, it starts getting tricky as to what else we can work out. So I was looking at triangle BFC and working out if I could work out that angle BFC. But it doesn't seem to really be getting us anywhere. But if we just look at this from a slightly different perspective, if I think about triangle BEC, well, I have an expression for each of the angles here. So let's have a look at that. So, oh yeah, pen is there, that's fine. Right, so if I look at triangle BEC, I know that x plus y plus z equals 180 degrees, because angles in a triangle sum to 180 degrees, and then x plus 2y plus z equals 180 degrees, which is what I was trying to show. So there we go, we're done.